to expect for the test. So as already mentioned, the test is not today, obviously. It's scheduled for Tuesday of next week. So the test format I'm going to talk about right now. Everything I'm mentioning is in the content library, so you don't really need to write this down if you don't want to, but you're welcome to do that if you want. So you have one question converting degrees to radians, one question converting radians to degrees. You'll have one question about calculating arc lengths or parts of arc lengths. I'm not going to give you the formulas for those, so you'll need to make sure you have like S equals R theta and the other version there remembered. Yes, sir.
Is that just like the chart? Or
yeah, like the chart problem from the homework. Yeah. You'll have a problem where you have to calculate the perimeter of a sector. So again, that involves that arc length formula. You'll have a problem where you have to solve a right triangle. That means finding all its side lengths and angle measures. You'll have one question where I give you some standard position angles that you have to draw, kind of like you did on the homework quiz for that question. You'll have two questions where you have to find the exact value of something using the unit circle. The unit circle would be provided. You don't have to memorize that. You have one question where I give you the point on the terminal side of an angle, and you have to find the 6 ratios. So there you'll need to make sure you have memorized like the standard position angle definitions for sine, cosine, and tangent, like x over r and y over r and all that jazz. But not bad, because it's basically still just SOHCAHTOA, right? One question where you'll be given one ratio and the sine of another, and then be asked to find a specified ratio. Again, there we did several problems like that between the worksheet and the homework and the review. You'll have to, one question where you'll use the unit circle to evaluate an expression, kind of like you had on the review. There are the questions like sine of blah, blah, times cosine of blah, 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 plus tangent of blah, 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 or whatever. And then two questions about transformation. So one where we're given the parent function asked to describe the transformation in words, like from worksheet 2, and one question where we give you a parent function and then several transformations, and you have to find the final transform function after those transformations done in order, just like in at the end of worksheet 2, I think, right? That was a worksheet 2 question. I think you had several of those to practice on. Do you guys have a pretty good idea like what we're going to be looking for on the test? Does that help? Hopefully winnow down your studying stuffs. Elizabeth?
Can you go over the homework, please?
The one from last time?
Yeah.
Let's see.
Like the one question about like, I think it was like the second question.
We have a second.
Oops. Let's look. Oh, thank you. Let's see. Let's see. I think everybody's taken it by now.
Are you guys really? Yeah. We go around at lunch, man. Go down at 1:30. We leave class at 1:35. Oh, I meant walking down 150, right?
Minutes is not that big of a deal. What are you going to do in 5 minutes? Unless you're interested.
I don't think it's 1:15.
All right, so this is what you're asking about, correct, Elizabeth?
Yeah.
So you're asking about this one, right?
Yeah.
Okay. So first thing I did was solve for excuse me, thank you. First thing I did was solve for this side AB using the Pythagorean theorem. Hopefully that's cool how to do that. Now to solve the angle measure, what I'm basically going to say is that, for example, I would say sine of angle A is going to equal 4 over 10. To get the angle A by itself, I would then need to do like sine inverse of both sides. So I'm really going to be doing sine inverse of 4 over 10. And quick, let me check that I'm in degree mode. I am. So there's my 23.58 degrees. And similarly, if I'm finding angle C, I can say that cosine of angle C is adjacent over hypotenuse. And do the same thing. Take cosine inverse of both sides. So I'm going to do cosine inverse of 4 over 10. And there's my 6642. So again, if you're looking for an angle measure, you need to use the inverse trig function. If you're looking for a side length, you're going to use the standard version. You're welcome. Other questions that anybody has, homeworks, reviews, worksheets, whatever. We'll take a few minutes and give you some time in class to work on that stuff last time, so I imagine some stuff might have come up in between. Josh?
Did you like highlight out the review? No. Like, never mind. That was a dumb question. But like, I don't know, some stuff on the review is like not on the test.
Correct.
Could you like, I mean, we'll still do it for homework, but could you like cross it out? Just, never mind. Figured I spoke.
Okay. I mean, like, you're welcome to go through and look at my list of things and be like, okay, this question isn't on my list of things, so I'm going to just like remove it from my study list. Like, I would do that for sure, right? I'm telling you the stuff to study, and it's not necessarily all of it. The whole review isn't necessarily on the study list. So you can certainly, if it didn't make the list of things I described here at the start, I wouldn't spend a lot of time reviewing that stuff. Absolutely. Am I going to do that for you right now? No, but you know, that's part of like one of those soft skills I'd like you to kind of work on your own, is being like, okay, we had all this review stuff, we did all this work, the teacher tells me these are the things I need to do. So like, let me go through now and figure out like, what is it that I'm actually going to have to study from the stuff that we did. You know what I mean? So I know that kind of is stinky, but it's a good skill to practice. Margot.
On page 5 of the review, could you please do F?
Sure. So page 5, you say?
Yeah. That one.
Okay. So it says, find two angles coterminal with each given angle. So in F, my given angle is in radians. So I can either add or subtract 2 pi from this. So for the sake of argument, I'll just say I'm going to add. It doesn't really matter. So to add these two fractions, I need to make like a common denominator. Clearly that common denominator would be 4. So negative 7 pi over 4 would be 1. And then I'll just add 2 pi again to get another. It doesn't specify what exactly those two coterminals angles need to look like, whether they need to be positive or negative or whatever. So I'm just going to add 2 pi again. I'll skip making the common denominator step and just write 2 pi is 8 pi over 4. Because like, why am I going to do that work twice? Right, I just did it. So my other one might be pi over 4. there's infinitely many answers to this, so if the answers that you came up with don't match what I did, it doesn't necessarily mean they're wrong, because there's, well, infinitely many of them. Is that okay? You're welcome. Josie?
Can you do H on the same page?
Sure. So same idea, right? So let's say we'll add 2 pi again. Why not? Who cares? It doesn't really matter whether you're adding or subtracting. So we'll make our common denominator here. That common denominator is definitely 3. So 7 pi over 3 plus 6 pi over 3 gives me 13 pi over 3. And then we'll just do it again. So add 6 pi over 3 again. So that'd be like 19 pi over 3. And if you're ever like, yo, fractions aren't my jam, like I feel very apprehensive about dealing with this kind of stuff, your calculator can handle all this stuff for you also. So if I wanted to do like 7 pi over 3 plus 2 pi, I'm just going to drop the pi's and just do 7 over 3 plus 2. And then if I hit the math button and select the fraction command, it'll give me that as a reduced fraction. And I just slap the pi back on there. So you can do that also if you feel hesitant about your fractional abilities. Or you just want to check, you know, sometimes despite the best laid plans, we make oopsies. You know? No big deal. You have the calculator, might as well check with it. Margot!
On page 4, can you please do
Yeah, let me grab that again. Page 4, you say? Okay. And which letter did you say?
D.
D. Sure. So cosecant, I know, is hypotenuse over opposite. So I'm going to now draw my triangle, label my theta. Opposite my theta is this side, and the hypotenuse is that side. And then I'm just going to use my Pythagorean theorem to find the other side. We'll call it x. So 169 is 13 squared, 144 is 12 squared, so 169 minus 144 is 25. And when I square root both sides, I get 5. So that side is 5. Cool with that?
Yeah, that's all right.
And then with just filling in the blanks with SOHCAHTOAs from there, right?
Yeah. Okay.
Are you good with that?
Yeah.
I can write them all down, but
It's okay.
if you want me to, I'll be happy to do it. I just, if you're good without it,
I can work on the key if I really need to.
yeah, the hardest part is making sure that you've put the sides in the right spot.
Yeah.
So the key is there when you draw your triangle, decide which angle is your theta, and then put your labels,
Okay.
your side length labels on there relative to that theta.
Got it.
You can't do it the other way around. You can't put the side lengths on there and then put the theta on.
Okay.
Raylan,
Can we do B on page 8
B from page 8.
or 7?
7. Okie dokie. Okay. So on here, we're going to be using the unit circle to evaluate these things. So I noticed that negative 135 and positive 855 are not unit circle angles. So I'm going to start just by adding or subtracting 360 from them until I get something that's on the unit circle. So negative 135 is the same thing as positive 225, just by adding 360. And 855, if I subtract 360 once, I still don't get a unit circle value. So I'll do it a second time. So that's going to be cosine of 135. So now I'm going to go to my unit circle. Sine of 225 is negative, is the y. So it's negative root 2 over 2. And cosine of 135 is the x, so that's negative root 2 over 2. So if I have two things that are the same, and one's in the numerator and one's in the denominator, that just turns into 1, right? And I'm done. Yes, since you're using the unit circle definition is that R is 1. Yes. Yes. So if you're in a problem like, these ones, R would likely not be 1, where you're given a point on the terminal side. So really we have 3 definitions for sine, cosine, and tangent that we've worked with in this chapter. SOHCAHTOA, the point on the terminal side definition, and then the unit circle definition. So SOHCAHTOA, like opposite over hypotenuse, all that. Point on the terminal side, like y over r, x over r, all that. And then the unit circle is where the r's are 1. Okay, so 3 different definitions depending on the context that you're working in. And that tends to be the trickiest part for students, is making sure they're using the correct definition in the correct context. You're welcome. And should you have those definitions memorized? Absolutely, right? That would not be something that would be on there for you. You need to know SOHCAHTOA. You need to know like y over r. You need to know like y over x, depending on the 3 different sets of definitions. But it's not hard, right? They're all just kind of SOHCAHTOA. Right? Just opposite is y, x is r, or x is adjacent and r is hypotenuse, and it's basically SOHCAHTOA. Margot.
On page 6, can you please do E?
Yeah, sure. 6. Should just taken the whole thing at this point. Okay, so we want to use the unit. Okay, so find the exact value for this. I'm going to do this using the unit circle. So I noticed that 9 over 2 pi is not on the unit circle, right? So again, I could do this by, adding or subtracting multiples of 2 pi to find something on the unit circle. So I'll just do this on my calculator. So again, I'm dropping the pi's. So instead of writing 9 pi over 2, I'm just going to write 9 over 2. And instead of subtracting 2 pi, I'm going to just subtract 2. And I'm looking to get an answer between 0 and 2. So 1 subtraction, not enough. 2 subtractions is. You good with that?
Yeah.
Okay. Turn that into a fraction. So this is the same thing as cotangent of pi over 2. So I'll go to my unit circle. Actually, we'll just copy it and drop it into the same document. I know that cotangent is x over y. So I find pi over 2. The x is 0. And the y is 1. So I have 0 over 1, which is just 0. And I'm done.
Okay.
Is that okay?
Yeah.
Alternatively, if you didn't like doing the subtractions, you can find these coterminal angles graphically when you're operating on the unit circle. So if I'm doing 9.5 pi, that's basically 4.5 pi. So half, 1, 1.5, 2, 2.5, 3, 3.5, 4, 4.5. And you can count around the circle like that and just do it visually. It's okay to do that also. If you prefer, as long as you know the angle that you're looking for is a unit circle angle, it's easy to just kind of like count around to find the thing that's coterminal on the unit circle. If you're just finding something that's coterminal and you don't know it's a unit circle angle though, like less effective.
Okay.
Cool. Who's next? And again, Margot, more often than not, like there's lots of different ways to kind of approach these trigonometry problems, whether it's like really arithmetically, like doing like computation, or sometimes it's often easy to do it visually.
Okay.
And I'll often try to present both ways of doing these things.
Okay. Thank you.
Yeah. Elizabeth?
Can we do number C, like the second C on page 6?
Sure. This one right here?
Yes.
Okay. So we're going to ask, or we're asked to find tan theta if cosine theta equals negative root 2 over 2 and sine is positive. This is definitely the kind of a question that would appear on the test. So a good one to ask about. I remember that cosine is equal to x. So I know the x coordinate is negative root 2 over 2. And I know sine is y. So sine is, or y is positive. So right away, I can tell that I have to be working in the second quadrant because that's the place where x is negative and y is positive. So this is where my theta is. Everybody's okay there? So now I know that cosine, since we're operating in a, I'm going to think about this as like y over r. So I'm going to, or x over r. So I'm just going to call the r1. Or even you could, even you could do it this way and say x is negative root 2 and r is 2. That would be okay to do it also that way. Let's do it that way. That's probably just going to be a little bit simpler. And so I can use the Pythagorean theorem now to find y. When I do that, it's going to be root 2. Right? 4 squared equals square root 2 squared plus y squared. Square root 2 squared is 2. 2 squared is 4. Subtract the 2 over. Square root both sides. Are you okay? I don't have to write it down? Okay. And so now all we're left to do is find tangent. So you can think about it as like, okay, here's my x and here's my y. So I know tangent is like y over x. Or you could think about tangent as like opposite over adjacent. You could think about it that way. I missed the negative sign on my 1. Either way of thinking about it is fine. Once you've drawn that reference triangle, you can use kind of any of the definitions and it'll probably be okay. Is that all right?
Yes, thank you.
Of course. Alternatively, if you're real clever, you could notice that like, yo, that's a unit circle coordinate, right? So I'm just going to go to my unit circle and be like, where is x negative root 2 over 2 and y positive? It's here. So I know the y coordinate is that. And I could just do it like a unit circle problem. Since I noticed in this particular case that cosine theta is like a unit circle value. Now that's not usually the case, right? That's specific to this particular problem, but you could have gotten away with like, yeah, I know what it is right away. Like it's just a unit circle value, so I'm just going to use the unit circle to do this. But that probably wouldn't have been the obvious first route. Although the easiest, because you don't have to build anything, you're just like, oh, I have everything I need right here. But, just trying to connect these ideas back together, right? Sure. Sure. The same problem?
Yeah.
Sure. So we know that tangent is y over x. So I know that y is 2 and x is 1. Or y could be -2 and x could be -1, right? And I know that sine is y, and that's negative. So this is the situation really that I have, where x and y are negative, because I know y has to be negative. So if I draw my picture then, I'm down here in the third quadrant. So my y is -2, my x is -1. And if I do the Pythagorean theorem, my r is the square root of 5. And I know secant is x over r. So that's going to be -1 over square root 5. And we need to rationalize the denominator there. So that'll be -√5 over 5. Jackson? Sure. Zach?
Isn't it r over x?
Oh, goodness gracious, you're right. Raylan, I just goofed up. I got going too fast. R over x. Thank you. That's even easier, right? Because there's no radical in the denominator, so one less little thing to do. Thanks, brother. Again, if you see me making mistakes, make sure you say something. Don't let me keep making mistakes. That's rude. As soon as you see me, be like, oh, wait a minute. Don't even let me write the next thing. Interrupt. You just be like, wrong. It's okay. I got thick skin. I won't get mad about it. Unless you're wrong about me being wrong. And then I might give you a little bit of grief about it, but there's nothing personal. Alyssa.
On page 5, the second section on it, to find r, is that just the square root of x squared plus
Y squared.
y squared?
Yep.
All right.
Absolutely.
Perfect.
Yeah, no problem. Any other questions? Yeah. You ready to do it?
Oh.
Are you joking?
No.
Why is there really before test?
Well, because you guys all complained about the last homework quiz that was too fast. It's like I haven't even had a chance to do anything yet.
No, but
So now we're doing a homework quiz. We'll do a homework quiz now, where it's like you've had a chance to work on everything. In fact, you had a bunch of time yesterday to really kind of plow through all the kinds of questions that could be asked. So I think it should be things that are very doable.
Can we do a partner quiz? That'd be so cute.
I agree with that.
That's a really good idea.
Yeah.
We'll not do that today, but I'll keep that in mind as a possibility in the future.
We saw that.
But yes, that is how it goes. You should be able to do pretty well. That was my intention when I wrote something.
Oh,
So it's like, I don't know. This is intended to be it's like something you can do in about 3 minutes if you know what you're doing.
Is it all questions?
There's like one multi-part question and a second question.
Only two.
There's only 2 questions. There's not much to do.
Whoa, what is that?
Unit circle. Because you need to use the unit circle to do the questions. So I just put it in there.
Oh, I remember this.
Yeah. In fact, we did examples of all these kinds of things
Yeah.
just a minute ago. So if you were like paying close attention, you should be like, yo, I'm good. I can't say that you will be, but like, you should say that, you know.